Well, in this video, we're going to look at another example from Chapter 7, chi-squared hypothesis test for a goodness of fit, and then we have the chi-squared test for association. So I'm looking at example 3, and I want to make sure to go over these 5 steps, and maybe not the exact order, but I want to state the hypotheses in plain English, give the chi-squared test statistic, degrees of freedom, p-value, make sure we have expected counts of at least 5, come up with a decision for the test using that p-value, and then write a conclusion. All right, so for example 3, there's some data compiled. This was over a number of seasons of the four major sports in the United States: basketball, baseball, hockey, and football. So not a full season. These are samples because baseball has a lot more games than the rest of these. So kind of random samples. And this is over the same city. So I want to know, like, does basketball have more of a home field advantage than, say, baseball or hockey or football? And we're going to use a significance level of 10% to answer this question. Right? Does one sport have a much stronger advantage than another sport? All right, so we're looking at home playoff or home wins versus home losses, and 4 different sports. So since there are 2 variables, right, that would be home wins and losses and sport, or the 4 different sports. We're going to start by conducting a test for association. I want to see if there's an association between home team advantage and sport. So for the null hypothesis, we assume there is no association between home advantage and the 4 sports. All right, for basketball, baseball, hockey, and football. All right, so if we have different sports, we have different advantages, but we're going to look at home advantage and 4 sports. So assume no association. The alternative hypothesis is that there is some association between home advantage and the 4 sports. Okay. All right, so kind of looking through, we've got the null alternative hypothesis. I want to compute the test statistic and degrees of freedom, p-value. Let's see, I think we could do degrees of freedom. This is going to test for association. That's R minus 1 times C minus 1. So the number of rows, not counting the labels, are 2. We're looking at home team wins, home team losses, 2 options. And we're going to multiply that times 4 minus 1 because we have 4 columns. That's going to equal 3 degrees of freedom. All right, if I want to compute the test statistic, the test statistic is chi-square equals, to actually compute this value, I'm going to go to stat key. Let's go right here. All right, in stat key, to get your test statistic, it's going to be one of these 2 options down here in the more advanced randomization tests. We're looking at a test for association. Notice right here, the null hypothesis just says no association. That's small, you see that in one thing, no association. I'm going to click on that edit data, delete all this, and we have basketball. It's a little easier here to see. Basketball, baseball, and let's see, hockey and football. And home wins, 127, 53, 127, 53, 50, and then 57. So for basketball, baseball, hockey, football, and then home losses, that's going to be 71, 47, 43, 42. All right, let's add the data in. I'm going to click OK. And let's see, we have our sample right here, including all the totals. I'm going to click on Show Details just to go look a little bit deeper. For basketball, the home team won 127 times, but if there's really no association between the sport and advantage, basketball should have won 116. So it looks like basketball outperformed. Baseball, the sample 53 times the home team won, but they should have won 58-59. For hockey, they won 50-50, but they should have won if there's no association, 54-55. And football won 57, but they should have won 58. Interesting. So it looks like from this, basketball looks like has a little bit more of an advantage just looking at the expected counts versus the observed counts. We'll maybe dig a little deeper in a moment. But for right now, I just want to note that chi-squared test is 4.783. Oh, and also note the expected counts here are all over 5. The smallest value is 38.5. Oh, so chi-squared was 4.738. And each expected frequency is at least 5. 38 was the smallest, so we're okay there. All right, now I want to compute p-value. P-value is, I'm going to go back to stat key, and I need to enter this test statistic and degrees of freedom by going into the theoretical distribution chi-squared. It was 3 degrees of freedom. Click OK. Always right tail for chi-squared tests, and this bottom value is the 4.738. 4.738 with 3 degrees of freedom gives me a p-value of about 19%. So 0.192. Was that 92? Yep, 0.192. So with this p-value, we want to compare that to a 10% significance level. P-value is greater than significance level, so we do not reject the null hypothesis. The sample does not provide evidence that there is an association between home team advantage and the 4 sports. All right, so we do not reject, so we do not support the alternative hypothesis. I want to make a little note, even though basketball does have more of a home advantage. Advantage, according to this sample, it was not enough to warrant rejecting the null or the test of association. So maybe if someone's skeptical, they might want to get a bigger sample size or look at a different team. Maybe look at, well, we have some evidence here that basketball has a better advantage, but overall, it's not enough of an advantage.